All right, in this video, I want to go over some things that you learned in Algebra 1 about simplifying square roots that we're going to need in the coming sections. So the first is how to simplify square roots in general. So I've got a square root of 54 here, and I want to simplify that. Now, square roots basically operate upon the fact that you look for things that are already squared. The square root of 9, which is 3 squared, is 3. The square root of 16, which is 4 squared, is 16. So the way to simplify a square root is to take the thing that's inside the 54, and we're going to factor that. So that makes 6 and 9. 9 is a perfect square. And I'm going to go ahead and write that out. 6 is 2 times 3. So once I've fully factored it, there's a rule that says if you're taking the square root of a product of two numbers, you can break apart that product. So I'm going to break this up into the square root of 2 times 3 times the square root of 3 times 3. Now, this is the square root of 9. And whenever you have a pair of factors underneath the square root, they can basically come out as a single factor. Now here, I don't have a pair of factors, so those are going to stay inside. So this is basically 3 times the square root of 6. So I'm going to give you another problem to do on your own, and I want to see if you can do it. So I'd like you to simplify the square root of 24. Pause the video and solve it and simplify it. Okay, so here's 20 square root of 24. We factor it. That's 4 and 6. Now, at this point, I know 4 is a perfect square, so I don't have to factor that further. This is 2 and 3. So this is the square root of 2 times 3 times 4. That's the square root of 6 times the square root of 4. So this is 2 square roots of 6. Okay. Now, when you are multiplying or dividing square roots, the order you want to think about is you want to simplify first, and then multiply or divide. And it's the same thing with adding, the last one you'll see. So we're going to simplify this first, because if I multiplied it now, I ended up with a 4-digit number that I would then have to factor and then look for pairs of factors. It's kind of a mess. It's much easier to simplify before you multiply than it is afterward. So I'm going to take this 27 and factor it. 3 times 9. Oh, that 9's a perfect square. So I can pull that out as a 3, and then there's this 3 left behind. 72 is 9 times 8. Hey, look, a perfect square. But 8 can factor further into 2 times 4. Oh, that's also a perfect square. So let's see. The 9 would come out as a 3. The 4 would come out as a 2. And this 2 here is left inside. So basically, I have 3 square root 3 times 6 square root 2. And the rule is when you're multiplying or dividing square roots that the stuff that's outside interacts and the stuff that's inside interacts, but they don't interact with each other. So when I'm multiplying these things together, it's basically outside numbers times each other. So 3 times 6, which is 18. And then the inside numbers stay under the square root, 3 times 2, which is 6. And then I would look at that 6 and see if it simplifies any further. It doesn't, because there's just a 2 and a 3. So that would be my answer there. All right. So when you're doing adding and subtracting, much the same thing applies. Adding and subtracting radicals, kind of like adding and subtracting like variables, is all about like terms. So if I look at this thing right now, I've got a square root of 18, square root of 2 square roots of 8, negative 4 square roots of 24, 5 square roots of 8. So the way you know if radicals are like terms, if they have the same number under the radical, that's called the radicand. So you have 2 of them here that have the same number under the radical. I have 5 of those root 8s and 2 of those root 8s. So that means I have 7 of those root 8s. So the first thing I'm going to do is combine any like terms. Then I'm going to simplify any radicals that I see. So 18 is 2 times 9. That 9 would come out as a 3. The 2 would stay inside. 24 is 4 times 6. The 4 would come out as a 2. By the way, when it comes out as a 2, it gets multiplied. So there's already a 4 sitting there. So that would become an 8. The 6 is 2 and 3, so it just stays inside because there's no pairs of things, no perfect squares. The 8 is 2 times 4. That 4 would come out as a 2, get multiplied by the 7, so it'd be 14. And this 2 would stay inside. So then I look at what I have at the end and say, do I have any like terms that didn't appear as like terms in my original problem? And the answer is yes. These root 2's here. I have 14 of them and I have 3 of them. So it means I have 17 of those root 2's and I'm taking away 8 root 6. And I can't combine those anymore because these aren't like terms and nothing else can be simplified. So we're going to be using those skills in the coming sections.